Hi everyone, welcome to Chemicos Academy. So today we can solve some previous year questions of polymers and colloids. So let's move on to first polymers. So first question is the addition polymerization of M involves I to K, R is the rate constant is K1, and second step R plus M gives Rm, the rate constant is K2, and then propagation Rm plus M Rm2. Rmn plus Mnr gives Rmn Mn dash R. So this is addition polymerization reaction. So in addition polymerization reaction, the reaction proceeds via a free radical mechanism. So here a free radical is formed, that is the initiation step, and then propagation step, then the closing step, termination step. So the given data are the rate constant for free radical formation is 2 into 10 raised to minus 3 per second. The initial concentration of initiator is what? This I. Initiator is 10 raised to minus 3 mole. So the rate constant for free radical formation 2 into 10 raised to minus 3 and concentration of initiator 10 raised to minus 3. And overall rate of reaction is 4 into 10 raised to minus 3 mole per decimeter cube per second. Assuming steady state approximation for free radical, the kinetic chain length is. So we have to find the kinetic chain length. So how to find the chain length? The equation is kinetic chain length is equal to rate of propagation reaction. Rate of propagation divided by rate of initiation. So here the propagation reaction rate is the overall rate of reaction. So overall rate divided by rate of initiation. So rate of initiation is given. Rate constant for free radical formation. The free radical, the first step is the initiation step. Initiation. So we can substitute the values here. So okay, rate of initiation is what? K1 into I. Rate constant into concentration of reactant give you rate. So K1 into I is the rate of initiation. So substituting we will get rate of propagation, the overall rate. Overall rate is 4 into 10 raised to minus 3 mole per decimeter cube per second, divided by rate of initiation is K1 into concentration of I. So substituting 4 into 10 raised to minus 3 divided by K1 is what? 2 into 10 raised to minus 3. 2 into 10 raised to minus 3 into concentration of I. 10 raised to minus 3. So 10 raised to minus 3 cancel. Then 2 into 10 raised to minus 3 comes to numerator, 10 raised to 3, 2000. No unit for kinetic chain length. So options are 2000, 18, 10 raised to 9 and 20, 200. So the right answer is 2000. So how to find kinetic chain length? Rate of propagation by rate of initiation step. So if the concentration and rate constants are given, K1 into concentration of reactant gives you the rate of a step. Moving on to second question. During addition polymerization, the reaction proceeds via step growth process, cascade process, free radical chain reaction, addition reaction. So in first question it was addition polymerization. So there a free radical is formed, then the chain propagates. So the reaction proceeds via free radical chain reaction. So the correct answer is C. Free radical chain reaction is the proceeding reaction for addition polymerization reactions. So coming to third, the number average molar mass M bar N. Number average molar mass and weight average molar mass M bar W of a polymer are obtained by which method? So there was options: osmometry and light scattering measurements, osmometry and viscosity measurements, light scattering and sedimentation measurement, and viscosity and light scattering measurement. So the right answer is osmometry and light scattering measurement. So m bar n. M bar n, number average molar mass is n1 m1 plus n2 m2 plus etc. divided by n1 plus n2 plus etc. That is number average. Now again we multiply with m. M bar w is weight average is n1 m1 square n2 n2 square plus etc. divided by n1 m1. So I will write here divided by n1 m1 plus n2 m2 plus etc. So this is weight average molar mass determination. So this can be determined by, this can be get by osmometry measurement, and weight average is determined by light scattering, laser light scattering method. So there is another formula is there, m bar z. M bar z. So m bar z is z number average molar determination. So m bar z is what? n1 m1 cube plus n2 n2 cube divided by n1 m1 square plus again multiplying with m. So it is m bar z is equal to n1 m1 cube plus n2 n2 cube plus etc. divided by n1 m1 square n2 m2 square plus etc. So this is Z average molar determination. So Z average is determined by sedimentation method. So m bar n is determined by osmometry, then m bar w light scattering or laser light scattering method, and m bar Z gives you by sedimentation method. And m bar n is less than m bar w, which is less than m bar z. So this is the order. This value is greater here. So coming to fourth question, a polymer sample has the following composition, number of molecules and molecular weight is given. So for 10 molecules, the molecular weight is 1000, 50, 2000 and 40, 4000. So we have to find the PDI of polymer. PDI is Polydispersity index. So Polydispersity index formula is PDI equal to m bar w divided by m bar n. So we have seen the formulas for m bar w and m bar n. For m bar w, the formula is n1 m1 square n1 m1 square plus n2 m2 divided by n1 m1 plus n2 m2, and m bar n n1 m1 plus n2 m2 by n1 plus n2 etc. So we can substitute the m bar w and m bar n in this equation and get PDI. So m bar n equal to n1 m1 plus n2 m2 plus etc. divided by n1 plus n2 plus etc. So n1 is number of molecules and n1 is the molecular weight of that n1 molecules. So here n1 is 10 into molecular weight of 10 molecules given as 1000 plus here n2 is 50 into 2000. Then 40 into 4000 divided by n1 plus n2 plus n3, 10 plus 50 plus 40. So 10 into 1000 plus 50, 10 into 1000, 10 raised to 4 plus 2 5s are 10 into 10 raised to 4 plus 4 4s are 16 into 10 raised to 4 divided by 10 plus 50, 60, 60 plus 40, 100. So you will get 10 raised to 4 common, 10 raised to 4 into 1 plus 10 plus 16 divided by 10 raised to 3. Sorry, 10 square, 10 square. So solving this, 27 into 10 raised to 4 divided by 10 square, which is equal to 27 into 10 square, to the, okay, 2700. Now solving m bar w. M bar w equal to what? n1 m1 square plus n2 m2 square by n1 m1 plus n2 m2. So substituting values. So m bar w equal to n1 10 into 1000 the whole square plus then 50 into 2000 the whole square plus 40 into 4000 the whole square divided by 10 into n1 m1, 10 into 1000 plus 50 into 2000 plus 40 into 4000. So solving this, 10 into 1000 the whole square. So 10 into 10 raised to 8. 10 raised to 3. 10 raised to 3 the whole square is, sorry, 10 raised to 6. Plus 50 into 2 square 4. 4 into 10 raised to 6. Plus 40 into 4 square 16. 16 into 10 raised to 6. Divided by 10 into 1000 plus 50. So we already solved this in m bar n. So that value we got is 27 into 10 raised to 4. So solving this, 10 raised to 6 common, 10 plus 50, 5 fours are 20. So 200 plus 16 into 4. 6 fours are 24, 1 fours are 4, 6, 640 divided by 27 into 10 raised to 4. So solving this, you will get 85 into 10 raised to 7 divided by 27 into 10 raised to 4. So now we have to find PDI. So substituting, m bar w is this one, 85 into 10 raised to 7 divided by 27 into 10 raised to 4. So now we have to divide these two values. So when you divide 85 into 10 raised to 7 divided by 27 into 10 raised to 4, the whole divided by 2700. So here comes 27 into 10 square. So 85 into 10 raised to 7 divided by 27 the whole square into 10 raised to 4 plus 2 6. So 850 divided by 27 square, 729. 10 raised to 6 and 7 cancel, 110 comes in numerator. So 850 divided by 729. So option 85,000, 27, 85 by 81, 850 by 729 and 729 by 850 is also there. So you should remember m bar w comes on the numerator. M bar w, higher value comes on the numerator. M bar w divided by m bar n is the polydispersity index of a polymer. So in fifth question, find probability of the link in polymers where average values of the links are given. So we have to find the probability of each link. So A, B and C links are there and the average value of the link is given. And the average values for A 10, for B 50 and for C 100. And the options given are the probability of A, B and C can be 0.99, 0.98, 0.90 0.98, 0.90, 0.99, etc. So we have to find the probability. So the equation for probability P equal to 1 minus 1 by K average. K average is the average value of a polymer link. So 1 minus 1 by K average is the probability of a link. So we can substitute the value of K average. So for probability A, PA equal to 1 minus 1 by K average of A. K average of A is given here 10. So 10 minus 1 by 10. So 9 by 10. 9 by 10 is 0.9. 0.90. So in given option for A 0.90. 0.90 is only two options left. So first option cancel, second option cancel. So these are the two remaining options. Now we can find PB, probability of B link. So 1 minus 1 by K average is what? 50. So 50 minus 1 is 49 divided by 50. So 49 by 50. So 49 by 50 is 0. 50 into 9 is 0, 5, 450. So 9, 490 minus 450 is again 40. So 450 can't be taken, so 8. So 0.98. So in option 0.98 for B. So third option is the right. So PC is what? PC equal to 1 minus 1 by 100. So 100 minus 1 is 99 by 100, that is 0.99. Okay, right. 0.90, 0.98, 0.99. So probability of a link is determined by 1 minus 1 by K average. K average is the average value of a link, given link. So probability is 1 minus 1 by K average. So the sixth question is, a 5 gram per liter polymer solution is prepared with a polymer whose molar mass is 25 kg. So the given concentration is 5 gram per liter and the molar mass is 25 kg. The osmotic pressure of this solution at 25 degrees Celsius is, so we have to find the osmotic pressure. So the equation for osmotic pressure is pi equal to CRT by M. So pi is the osmotic pressure, C concentration, R gas constant and T temperature and M molar mass. So here the concentration is given. So pi equal to, concentration is 5 gram per liter. So 5 into 10 raised to minus 3 kilogram into R. Gas constant. So the question is the atmospheric pressure, the osmotic pressure in atmosphere ATM unit. So for ATM, the gas constant is 0.084 liter per atmosphere into temperature is what? 25 degrees Celsius. So 25 degrees Celsius is 273 plus 25, 8. 7 plus 2, 9, 2. 298. 298. Divided by molar mass is 25 into, okay, kilogram, 25. So 5, 25, 5. So when you solve this, you will get 20, here 25, then 5, then 5 into 10 raised to minus 3. 5 into 10 raised to minus 3 atmosphere. 5 into 10 raised to minus 3 is what? 0.005 atmosphere. So from option 0.002, 0.05, 0.005 atmosphere. So the osmotic pressure equation is pi equal to CRT by M. So pi is osmotic pressure, concentration, gas constant, temperature, molar mass. Now we can see some questions of colloids. So first question, dispersion of solid in liquid, a liquid in gas, and liquid in liquid is known as what? Aerosol, emulsion or sol. So we have to find the correct answer. So dispersion of solid in liquid. Solid in liquid is sol. Solid in liquid, S and N. So solid in liquid is sol. And liquid in gas. Liquid in gas. So gas means air. So aero and liquid all. So aerosol. So aerosol is liquid in gas. So this is aerosol. And this is sol. And now liquid in liquid. That is emulsion. So solid in liquid is sol. S and L, solid in liquid, sol. And aerosol is what? Air is gas and all is liquid. So liquid in gas, that is aerosol. And liquid in liquid is always emulsion. Now coming to second question, the aggregation of surfactant molecules is called, aggregation of surfactant molecules means the combining of surfactant molecule is called miscellany. So miscellany is the right answer. Clusters, gel and colloids are parts of colloidal chemistry. Colloids is, gel is a form of colloid. So the aggregation of surfactant is called, surfactant molecule is called miscellany. So in third question, the stability of lyophobic colloids is a consequence of electrical double layer, small size of particles and shape of the particles. So in lyophobic colloids, the lyophobic colloids are liquid hating colloid. So lyophilic colloid is what? Liquid loving colloids. So in lyophobic colloids, there is a theory, double layer theory. In double layer theory, it states that the colloids form two layers. The first layer is fixed layer of ions that have a charge also, depends upon the ions which absorb on the surface. So if negative ions are adsorbed, then the first layer will be negative in charge. And the second layer is mobile layer. First layer is fixed layer and the second layer is always moving, mobile layer. So these will create a stability in the lyophobic colloids. And also the lyophobic colloids are weak van der Waals forces. It have weak van der Waals forces. And this size is not small size. The stability is not due to the small size and the shape of the particle. It does not depend upon the shape and the size of the particles. It depends upon this double layer, that is called the electrical double layer of the at the surface of the particles. So fourth question, a dilute AgNO3 solution is added to a slight excess iodide solution. A solution of AgI is formed whose surface absorbs which of the ion? I minus, NO3 minus, Na plus, Ag plus. So let's say AgNO3 is added to a iodide solution which is Ki. So AgNO3 is added to Ki, which is excess. Now the question is, a solution of AgI is formed on the surface. So AgI is formed on the surface. AgI is formed. So on surface, which ion is adsorbed? So on this surface, which ion is adsorbed? So it will be either Ag plus or I minus. So this option is cancelled. So here AgNO3 is added to Ki. So here I, K plus and I minus are in excess amount compared to AgNO3. So definitely this AgI will absorb the excess ion. Excess ion means I minus. So I minus is absorbed on the AgI surface. So I minus is absorbed in the dispersion medium, from the dispersion medium.